Thank you. So today I want to talk not too much about Cowboy, but about a library that I've been using recently to build web applications. So as some of you may know, I'm not very good at client-side development. So I always try to find ways to avoid doing it and still being able to build my applications. So this is the best answer that I've found at the moment. And I will explain what it is, what we can do with it, what I'm actually building with it, and also a few tricks to make your life easier and to avoid doing extra JavaScript. So let's start. First, what I'm going to talk to you about was initiated by the LeoFS project, which is a distributed file system. It basically uses the S3 API to send you files, allow you to store and retrieve files. It's a big project. It's run by the Japanese company Rakuten, and it's reaching its first release very soon, first stable release very soon, probably in 1 or 2 weeks. So look at it if you are interested in databases, file databases at least. And so this project has potentially very big systems, and the LeoFS developers need tools to find out what's going on in their systems. One node could be busy doing something, and they need to know that, to figure out that a request that entered the system on a different node couldn't complete. So they need some kind of monitoring system and introspection system in the project. So they sponsored my work. The work is only started for now. It will end up being 2 tools. The project is Alien Shaman. I will explain both what they are. And this project is mostly inspired by Bigwig. So some of you probably have heard of Bigwig before. It's doing pretty much what Observer is doing, except with a web interface. And this tool won a prize at SpawnFest, the first SpawnFest we did. And it was pretty impressive, but 2 problems. The developers have never maintained it, so it still does exactly what it was doing 3 years ago. And it also doesn't do distributed. It's always on the local node, so it's not useful enough for what we need. I didn't go with Bigwig as the beginning of the code base. Of course, there are parts that are very common between the 2 projects, but they are not the important parts. Bigwig being local only means that there is no logic to handle events coming from any node in the system, and that's the big part of what I have done so far. And so I have 2 components. The first one, Alien, which is some kind of event library. It allows you to have probes inside a node, and these probes then send events to other locations that can be, I'll come to it. And all this ultimately ends up on the web UI that I will talk about today. So Alien has 3 different probes. We either want to monitor something all the time, or only when we click something on the web interface, or also every time we receive an HTTP request, for example. So we have these 3 probes, and then we allow to route these events pretty much anywhere. We can send them to another process on the current node. We can send them to a different node. We can send them over TCP, UDP, anything. Most of the work in that library is done. It's also pretty boring work, so I won't spend much time on it. This is the most interesting part. So Shaman receives all these events and then has to display them. If you have only one node, then there is only a few events. That's pretty easy to do. But if you have to display data for potentially thousands of nodes, you have to have ways to make the programming of this UI easier. So Shaman just receives events and then shows them. It can be events that are defined inside the projects themselves. For example, memory would be standard, but we could have any kind of data sent by the nodes. So we will have a pluggable interface and such. This is a work in progress. What's done so far is the interesting part, which is D3. So Shaman eventually will have, we will eventually want to store events on the disk to later retrieve them, like in a time series database or something. This part isn't done not, at the moment. So everything Shaman displays is only what happened since we started it. Nothing is kept in Shaman at all. It's all client-side. We will come back to it over the next few months, of course. And yeah, so let me show you what it looks like so far. So yes, so this is a very, I did not take the last version that I have in development because I broke many things. So this is one that I know works, but it doesn't do much. It only does a list of processes. So yeah. This data is sent from the local node. For this demo, I will only use the local node, but it could come from any other node. Well, this part in this version of Shaman doesn't receive from other nodes. It's only the new version that doesn't work yet that can receive from any node. But it works very similar. So we have a process list, and the data here is updated automatically. One important thing to note that I will explain today is that the update of this table here required basically no JavaScript code. I, of course, wrote a small library to automate this, but now if I add some more data to the table, I don't need to do any JavaScript. I will explain, of course. And I can look inside processes. And this is the same data with some more information. And similarly, if I had another value here, then I don't need to do any JavaScript programming. I need to do two things. I need to send it, of course, and then I need to update something in the HTML to display it. So we will look at what it's doing exactly. And we will see also graph a little. And yeah, and this model, which is a little more complex than just displaying a table. So let's go back to D3. So has anyone here used D3 so far? 1, 2, 3, okay. A few. So it's a library that, well, if you go to its web page, you can see many different graphs and animations and stuff. It's a library that can do that, but that's not all it can do, and that's actually not what it focuses on. It focuses on receiving data, seeing what came in, came out, and then updating the nodes on your HTML page. And these nodes can be normal HTML, for example, a table, or SVG, and such. And with SVG, you can then do the animations and the graph and so on. So it's a little different. It's based on data. It manipulates data. That's what it understands. It doesn't give you a function to draw lines. That's not what it does. It gives you functions to receive this data and then create some nodes, for example, SVG line inside your document. But it's absolutely not hard coding this at all. You can create a line using SVG or HTML if you want. It doesn't matter. Every time you give data to D3, it binds this data to the nodes inside the HTML document. So I will explain what it means in more details. But this means that we can simply query the DOM to retrieve the data we need. Most of the time we don't, but we will need it here. And then, you use just web standards. You use HTML, you use SVG, and if you replace D3 with another library one day, you won't have to rewrite everything. It's still the same old web standards. And of course, because it's standards, you can use features from browsers as soon as they come out. So if a browser starts adding some feature to add a sparkling colors or something, you can use it directly. You're not limited to what the library offers. And that's very, very useful. And also, it's standard, so you can easily debug. You can simply load up your inspector and go to the node and see what data it has and what was created, what were the nodes created, and so on. So D3 can be used to update data on your page. It can be used to generate the page. It can be used to draw diagrams. It can be used to do pretty much anything you want. And you only have to manipulate this data to do it. So it provides a few things to reach this goal. It provides selectors, which are a little different than, for example, in jQuery. We will see why. It provides dynamic properties. For example, I have a color for my cell in my table, and this color could be changing depending on the value I have. So instead of setting the actual value of the color, you simply set a function that then updates the color depending on the data. It has enter and exit selections, I will explain, and transitions. So if we want to not only display but also make transformations a little more cool, pretty much, with you have all the functions you need to do rotations and anything you want. So enter and exit, that's the very most important part of D3. Let's say I pass some data to D3. It will create, based on what the code I've written, it will create some nodes on the page with the data associated with each node. And then I pass some updated data. And this is where enter and exit come in. The data that wasn't available in the page yet will be found inside the enter selector. So I can, D3 filters for me what data is new so that I can create new nodes on the page for this data. And similarly, the data that isn't in what I give anymore would be inside the exit selector. And I can simply remove the nodes from the page. And of course, for everything else, I can simply update the value. So this is what it looks like. This one is pretty much what happens here in this table. Every time I receive data, I simply have a function that looks like this, which selects, OK, so I didn't explain selectors yet. So first, we want to select where we will be inserting data. So that's the content of the table. So that's this part. And then we select all the lines inside the table. But this function will not select all the existing lines. It's a function that will work even if there is no lines. When we give the data to this selector, it will figure out what data is already there and what data isn't. And using this, we can then filter the data that is there, that isn't there yet, and do an append of a line. And then similarly, the data that isn't there yet, we remove. So this selector here, means the lines in the table that exist and the ones that don't exist yet but will be created from my data. It's a bit different from a jQuery, which just selects what exists. And then for each line, I want to actually create cells to put the data. So this would be this one here is one cell, this one is another, oops, and so on. So we have to do something similar with cells. We select all the columns that are or will be created, and for each column we say we give this data. So there is a function here that I will explain in a bit. But basically, we say this column, this cell of this line contains this value. And we give these three both a key and a value so that it knows what data I'm giving it. And then similarly, if it doesn't exist yet, we append the cell, and then we set the value, and then we remove cells that were deleted. So actually, this call probably doesn't do anything because we have removed the row before. OK. And this here, we simply update the text of all the cells. So it will not only set the content for the cells that we create, but it will also update the ones that already exist. So that's pretty much how it works. It's also very similar for drawing graph. I won't go into details for graph, but I will explain a little. And for each of the nodes that I create, every time I call the function data, for each of the cells here, they will have the data for this cell bound to them. And it's bound inside this __ data property. So it's there. We can see it when we debug. We can retrieve it if we need to. We can even update it if we want to. So yeah, we can use it. We can use this to do things. Most of the time, it's not needed. So some of the things that I will explain will be a little, let's say, ugly. Well, they look ugly, but it's something documented, so it's not a problem. But yeah, usually it's not needed. So the API for accessing them isn't as pretty as the rest of the API. But the selectors we have here return a list of nodes, of elements in our page. So we can easily, more or less easily, access this data property when we need it. So this is one part. This is the part where we actually display things. Now, this data has to come from somewhere. It comes from Cowboy, of course. And for this, I simply have a WebSocket connection where I push any event I receive. So every time I receive anything, I just push it to WebSocket without syncing. So the WebSocket handler is actually very, very small. But the protocol has a few rules, of course. We don't just push data without syncing. So first I use, well, this isn't true in what I'm showing here. This one uses JSON still because I didn't want to lose time on this. But ultimately, it will use a message pack, simply because if I have to handle 100 nodes, I probably won't be able to encode the JSON for everything. Message pack is a lot faster. And yeah, the WebSocket connection encodes and decodes events, and it may encode more than one event at a time. So we send a list of events to the client. So the WebSocket part is very boring. The client part needs to have a little more code, but it's not that much either. So we have two things in the client. We may want to send commands. For example, I have here I can connect to a node. And then when I click connect to node, I simply send the command with what node I want to connect to. So we have these commands, and we also need to receive any data that the server sends us. So first, let's start with command. That's just we click something on the UI, and we send a request. The difference with simply doing an HTTP call is that Shaman will not care about sending a response immediately. It simply, the client doesn't wait. It sends this, and at some point, it will connect to the node here, and the UI will update automatically because an event will be received. Yeah, so we just send something, do it for me, thank you. Then what, well, this communication, sending, for example, a connect request or sending events to the UI, we have a very small, very small framing. We have basically 3 values. Well, the most values we have is 3. We have a type of frame. So this type is almost always data, because most of the events are, well, most of the communication comes from the server, so we simply send data. And the ones that are data also come with a key n and the actual data d. The key n is, for example, lists of processes, and the data would be the actual list of processes. Then, of course, I need some code to interpret this data. So on the JavaScript side, I simply allow registering handlers to handle not only each type of frame, but also each type of data. And every time I receive frames, for each event I have, I simply dispatch to the correct handler. So it could be the default handlers, or you could have your own JavaScript to add additional handlers. So yeah, for each event, we find the handler for the type, and we pass it the event. If it's data, we have another type of handler that handles the actual data. And then this handler will simply pass it to D3, and we don't have to do anything to update the page. So we don't have to do anything because of this. This is what the HTML looks like before this table here is populated. So here we only have a single node connected. But we could have any number of nodes. The important part is that for each column we have here, we simply define the data name property. This property, when we send data to the UI, the code will get this name, find the corresponding name in the data, and it will say, OK, I need to create a cell with the value for this key. And so that's why I don't have to write any JS when I add some more data. I simply add a new column with data name, and that's it. I then send it data, and it displays it. So this is the function that actually does the selection of this data name here, and that then returns the data that this tree will need to actually create new lines for this table. So it basically just it locates the part of the page where we have actually defined these data names, and then for each of them we simply get the actual value, and we return a key value with the key and the value of the data. And with this, we don't need to do any more work. We have two things to do when we add data. We add, of course, something on the Erlang side to forward it. And this isn't even in Shaman. This is something that you update in your probes. So that's something that you will just deploy to your system completely independently of Shaman. And you can do that at any time. If the data can't be displayed because it isn't defined yet, it will just be ignored. So you just add more data to your probes. And then when you want to display it, you go to the HTML and add the column or the line, and then it magically fills it the next time an event is received. So yeah, it's pretty boring after we have done this. The problem is solved where you don't have any work to do anymore. But yeah, that's not exactly true. So there is a few other things we can see. But yeah, this is, I think it's very powerful because we don't actually have to know what the UI is how the UI is done. We simply send it data, and that's it. From our viewpoint, that's the only thing we do. And yeah, we don't need to write any JavaScript, which is a big plus. So please, some applause. Thank you. And yeah, so we have a few more problems on the other hand. So one of the things I want to do is to avoid doing too much work on the probes because they are probes. They're not supposed to mess up with the actual execution of the node. So to avoid doing too much work there, I simply want to send as little data as possible with as little calculations as possible. And so I just push this data until we reach the JavaScript side. And here I want to do some calculations. For example, a very common calculation would be calculating the difference between the previous value and the new one, so that I can then draw a graph of what changed since then. Another problem we have is, well, this way is good because we can easily have data bound to one place. But it's also a problem because if I want to have a model, which, this data, either I have to duplicate it. Well, every time I receive data, I have to add more things, so I get my data duplicated many times on the page. And by that, I will come back to it. Or I can find a different way to manage it, but I will come back to it. And of course, I didn't cover graph at all, so I will show you some pretty colors. So yeah, client-side calculations. This is very important. This is actually one of the only requirements I have for the project. Everything else is just me finding interesting things to do instead of doing the actual work. But yeah, this one is the one that I spent the most time thinking about. And my solution was to simply send the data and then do the calculation there. But that's not that easy with D3. So I had to do some Google searches, try to find solutions, and there wasn't much. So I dug a little more and came up with something that I'm happy with. So this is it. So D3, we have the data that is bound to the nodes that are created inside the HTML. So we have data bound to this line. This line has the data property with everything inside plus everything we haven't displayed yet. And this line has the same for a different process and so on. So we can retrieve this data and then do something with it. We can add values. And actually, that would be this value. New reductions is actually data that is calculated client-side. So I had to do this, which may not look very pretty. There is a lot of this something, this 2, this 0, parent elements, so it actually means something very specific. This 2 means the third column. So I get this value. And then I get the new value, the new reductions, and then I just remove, subtract the old value. So I get the difference. And then I have to put the data back. So that's another, I use 0 here because it's guaranteed to be here if I have at least one. So it takes this, it takes the line, and then it updates the data. So it's a little ugly, but it works, and I will probably be able to create a more usable function for it. I just haven't come around to it yet, but it works. And once, so this is done when I receive the data. So this is before any cells are created or updated. So that's pretty good, because after that, this tree will simply give me the value that I want when I actually create the node. And that's pretty good. It's actually surprising that it actually works. I thought I was going to need to do a little more, but no, that's it. So we can do some client-side calculations. Of course, one thing that you may wonder is, if I have 1,000 nodes, then perhaps doing all the calculations inside the client will be a bit too much. But I'm not there yet. So another thing is that the data needs to be pushed to different destinations. The thing is that if I go to the list of processes and then click I have the model that is opened. I, of course, don't want to create a model for every process possible. That would be crazy. I have almost 500 processes running on this node, and it's not doing anything. It's just running Shaman. That's it. So that would be a lot of HTML generated and updated every second, and that's I can't do that. So I need to have some special case. When the model is open, I simply populate it with data. So what I need to do is to get this data that is tied to the row I'm actually clicking, and then do something with it. So that's probably the worst thing that this tree doesn't provide. You will see the code is worse than the previous one. And yeah, so I explained this already. So this is the code. What I'm actually doing is, basically, I click here. This line has an ID that a PID that I simply reuse to find the actual node. And I'm forced to use the filter function. I don't remember the details exactly, but the filter function returns a list of two things, and yeah, that's not the prettiest, but I still get my data, and that's what matters. So similarly, I will probably try to make this a prettier function and hide this stuff. But I can get my data, and then I can assign that data the same way I send data to D3 every time the WebSocket receives it. So I simply select the model. Of course, I have the HTML for the model defined in my page. By default, it's just hidden. And I just populate the table in there with this data. And it works the same way, except, of course, instead of having a table with columns containing the data, I have one piece of data per line. But otherwise, it's still the same. I have my HTML with data name, and I simply find it and put the value instead. So it's still, it's all I need to do to send the data. And then, yeah, it works. And yeah, so the last thing I've been working on was the graph that you can see here. So this graph is actually the value that I calculate every time, the new reductions since the last update. And so this is more or less equivalent to showing CPU usage, except, well, we don't see much, but there's a number here which tells me this is that many reductions. We see there's a problem if suddenly this number goes times 100 or something. But this is a very small graph. This one is just informative, what is happening right now. So graph like this, we need to accumulate data. Every time we receive data and we calculate this value, we have to push this value inside an array. And then we send this array to the D3 function that will draw out the graph. So there is, well, I did the actual drawing of this graph myself, but there is, oh, it's not doing much, this one. There is actually no need to write the JavaScript yourself to draw a graph. There is a library of many different graph and various visualization methods and such that you can simply reuse. I will probably adapt a few to work with Shaman so that they can just be reused. And the cool thing is that because you only manipulate data, then if you aren't happy with this representation, you will be able to simply click on a list, select a different type of graph, and it will just update automatically and switch the representation. So the data is truly separate from the actual display. And we can do anything we want with it. So this is the small example. Here, I simply have an array where I push every time the new value. I only keep the 60 last for the 60 seconds. And then I send it to the graph, and it updates automatically. So that's already covered. So now, well, I have the very basics of the system. I have done everything I could to avoid the boring work. So now I need to do the actual work. And what we want to have is, well, of course, we want to start with replicating the functionality of Bigwig, because this is pretty much what allowed me to sell it to Rakuten. And of course, what Observer is doing. So we want to be able to do that, except distributed. And of course, we want to be able to display this information better, well, in a good way, because we will be able to see information about many different nodes, and we have to find a way to properly display it. So we will see what comes up with this. And another thing we want is to simply forward all the logs that the nodes are producing to a single place. And so we will need an interface. So about logs, one thing that Alien already allows is simply accumulating the logs for, let's say, 1 second, and then send this to the socket in one go, so that we simply avoid just sending too many packets at a time. We can do some optimization like this to reduce the footprint. And we can also compress them if we, there are some very efficient, well, there are some algorithms for compressing text that do not use much CPU, so perhaps we will use this. Another thing, and that one is more of a pet ID. I want to be able to trace a system. Let's say I have 2 nodes. I do an HTTP request on one node, and I want to see what happens not only on this node, but also the life of the request on all the nodes of my system. So for this, Erlang comes with a tool that is called TTB. TTB is pretty much like the DBG tracer, except it works over distribution. So I will try to experiment with making an interface that allows me to visualize what happens. And yeah, thank you Erlang, because I would not want to write a TB itself. It looks very complex. And finally, we want to be able to attach this system on any node, even the ones that don't come with it directly. So that means we need to push the OTP application using distribution, load it, start it, and then we can use it normally. So that's another thing that I want to do personally, and I'm hoping I will find the time. And finally, of course, we need a nice logo to make it pretty, use special effects, make videos, and such. And with Alliance Shaman, we can have many different, very nice logo, I'm sure. And we're done. So if you have any question, now is the time. But before that, let me just say, so far I've been doing mostly consulting in my work. I'm trying to move to doing only open source only open source projects. And for that, I need some companies to sponsor me. So if you love Cowboy and you want to help me, please send me some money sometimes. No, I'm sorry, but yeah, this would be very good because then I can spend all my time on projects that benefit everyone. And yeah, if I can do that, I would be very grateful. Thank you. So any questions? No questions? Did you like it? Yes. Yes. Good. Okay, thank you.